We're solving problem 23 from the AMC 10B from 2020. Square ABCD in the coordinate plane has vertices at points A, 1, 1, B, negative 1, 1, C, negative 1, 1, and D, 1, negative 1. Consider the four following transformations. L. A rotation of 90 degrees counterclockwise around the origin. R. A rotation of 90 degrees clockwise around the origin. H. A reflection across the x-axis. And V. A reflection across the y-axis. Each of these transformations maps the squares onto itself, but the positions of the labeled vertices will change. For example, applying R, then V, would send the vertex A at 1, 1 to negative 1, negative 1, and would send the vertex B at negative 1, 1 to itself. How many sequences of 20 transformations chosen from LRHV will send all of the labeled vertices back to their original positions? Okay, so here's like the square. It's pretty small. There's 20 transformations, and there's four, you have to apply 20 transformations, and there's four different transformations you can choose from. Therefore, there's going to be a total number of 4 to the power of 20 ways, or 2 to the power of 40 ways. Now, so say you put a rotation, you use L, a rotation counterclockwise around the origin. That means A goes here, C goes here, D goes here, and B goes here. There's a 1/4 chance of selecting that. But if you choose R, then that means it'll return back. So 1/4 times 1/4, this is going to be 1/16. Now you can multiply these two together. This is 1/8. You multiply it by 2 because you can switch this around. But do we divide 2 to the power 40 by 8? Well, no. We have to multiply that by 2 again because there's another set of transformations. You can do H and V. So this is really just 1/4. And what is 1/4, you may ask? Well, you have to divide this by 1/4 to get the total number of ways, because as we just found out, there's 1/8 for every set, like L and R, and there's 2 sets. So 2 to the power of 40 divided by 4. This is going to get us our answer, 2 to the power of 38. And the reason why I wrote it in powers of 2 is because that's what the answer is on the test in powers of 2. That is going to be your answer.